we were doing this question when we left off the other day. We were wrapping up part B. So to do part B, you got to find the reference angle. So we figured out that we were dealing with cos theta equal a quarter. Use inverse cos to find that, and because it says to do it to the nearest degree, you get theta r is 76 degrees. Alright, from there you need to draw yourself a fancy picture. Okay, and you need to ask yourself, well, where is cos theta positive? So that's going to be quadrant 1, quadrant 4. Remember, you're just looking for where x values are positive. So in quadrant 1, when you draw your little diagram, here's my angle of 76 degrees. So in quadrant 1, the answer is the reference angle. And that is always the case in quadrant 1. In quadrant 4, when we draw this out, so here's my reference angle, 76 degrees. Well, we want to find theta, which starts here on the blue dot, goes all the way around until we hit that terminal arm. So to do that, I'm going to remind you that this here is 360 degrees. So we're going to go all the way around and land here. So that's the same as starting at 360 and then moving back 76 degrees. So we're going to go 360 minus 76, and we'll get something. We'll get 284. Like that. We've got two answers. That's the positive angles. The question's asking us to do from negative 360 to positive 360. So when we do our negative angles here, draw the sketch again. And for negative angles, this is 0 degrees, this is negative 90, negative 180, negative 270, yo. And once again, we can find our positive angle in quadrant 1 and quadrant 4. So this time, when we sketch it in quadrant 4, remember, we're going backwards. So that is negative 76 degrees. So that is going to be one of our answers. Okay, doing it in quadrant 4, we'll get our sketch. We'll draw our reference angle, 76 degrees in there. Okay, but if we're doing the negative angles, we're starting here and we are moving clockwise till we get to here. So once again, you'll have to do some thinking. Now this is 0 degrees and it's also negative 360 degrees. So if I start at negative 360 and move back 76 degrees, I'll be hitting that terminal arm. So the answer for this one is going to be negative 360. We're moving backwards, so we're going to add 76 degrees to find out that we've gone negative 284 degrees. Okay, so there are 4 answers for part B. We should list them all out in no particular order down here. So we had 76 degrees, we had 284, and we had negative 76, and we have negative 284. Okay, now I also want to point out that it is a complete coincidence that the negative angles and the positive angles have the same numbers, just different signs. That does not happen every day, but today is a special day. So that is part B. Okay, last question is, well, it's different. So I'm going to give you an angle, and you're going to go backwards, you're going to find trig ratios. Okay, now if I was to do a really basic example of this, if you're looking at your Radians handout, so here it is, coming up on the screen. If you're looking at your Radians handout, for example, if I said, hey, you got an angle of 30 degrees, so here it is right there, you know, what is sine 30 degrees? Well, sine is the y value. Okay, so you would say sine of 30 degrees is a half. Now if you take a moment and you plug that in on your calculator, if you go sine 30, as long as you're in degrees, you're going to get 0.5 as the answer. Go ahead, give it a shot. Alright, so if 2 of you did it, that'd be great. That's what we're doing in this question. The only difference is that, well, the angle might be something different. So here they're saying 510 degrees is the one that we want to figure out the 6 primary trig ratios for. So first of all, 510 degrees doesn't land on our 0 to 360 circle. So we'll just find a coterminal angle for it, because that'll be the same. So if we subtract 360, you get 150 degrees. Okay, now that's the angle in standard position. We need to know the reference angle. So if this is 9, or this is 0, that's 90 degrees, that's 180, then I can see that, okay, so 150 degrees lands somewhere in quadrant 2. So let's sketch it. There's 150 degrees. I'm interested in the reference angle. Okay, so to get from 150 to 180, that's going to be 30 degrees. So that is going to be the reference angle that I'm going to be using to find my angles of 510 degrees. Okay, the only thing I need to keep in mind is that we are in quadrant 2. Okay, so if we're in quadrant 2, that will affect the signs of certain things. Like in quadrant 2, sine, that's like your y values, that's positive. Cos, well, that's your x values, that's negative. And tan theta, that's the ratio of sine over cos, or y over x, well, that's going to be negative overall, because remember, cos is negative. Okay, so we'll keep that in mind as we're finding our angles. So if we go ahead and say we find sine of 510, okay, so we know that the reference angle for that is 30. If you bring this over here for a second, if you look at 30 degrees and you look at sine, or the y value, you see 1/2. Well, that's our answer for sine 510. You know what? If you go plug sine 510 in your calculator, you're going to get back the answer 1/2. Try it out sometime. If you do cos 510, again, remember, we're looking at the reference angle 30. So you go back here, you go to 30, and the cos value, well, that's the x value. So that's square root 3 over 2. Now, we are in quadrant 2, actually, because the equivalent angle is 150 and 30 is the reference angle. So in quadrant 2, we said that cos is negative, so make sure that you put a negative in there. If you do tangent 510, that one's going to be a little bit more work, because we need to do the ratio of y over x. So y is 1/2, x is square root 3 over 2. So you would have done this in grade 11. So you got to do that. Got a complex fraction here, but remember, it's the same thing as the thing in the top, or the numerator, times the reciprocal of the bottom. So when you do that, the 2's are going to cancel, and you get 1 over square root 3. Okay, and we're actually in quadrant 2, so we need to make sure we throw a negative on there. Okay, this might be something that you want to memorize, is the tangent values in quadrant 1. Okay, we need to do all 6 trig ratios, so for the other ones, we're going to go ahead and we'll do the inverses. So sine 510 is 1/2. The inverse to sine is cosecant. So if you do cosecant 510, it's also going to be positive, but the reciprocal is 2. The reciprocal of this thing is secant 510. Alright, do the reciprocal, so still negative, but now it's 2 over square root 3. And I apologize, when I was talking about this one here, I might have said secant, I meant cosecant. My bad. My B. This one here, so tan, we'll do cotangent 510. So again, just do the reciprocal. So it's square root 3. Don't lose the negative. Negative square root 3. And there's your 6 trig ratios. For part B, it's not a particularly important question. You're just plugging it in on your calculator. So we'll skip it for now. Last slide here. This will maybe clarify why I was talking about how when you go to this and you're at 30 degrees, your y value or your sine value is 1/2. Why is that? Well, we're usually working on something that's called the unit circle. So in the unit circle, the radius of the circle is 1. So when you solve this, you get x squared plus y squared equals 1. Watch out, because sometimes they have theory questions on that on the exam. Let's see what happens to sine theta, cos theta, and tan theta if r is 1. Well, sine theta is y over r. But if r is 1, then it doesn't really matter what I meant to say is that if r is 1, well, y divided by 1 is just y. So that's where we come to the conclusion, hey, sine theta and y are the same thing. Okay, so that's why I say, hey, if you're looking at an angle of 30 degrees, your sine value or your y value is a half. We're going to be using that fact a lot. Look what happens to cos theta. Well, again, it's x divided by r. So if r is 1, no, x divided by 1 is x. And for tan theta, that stays the same because y and x can be anything. Alright? So we often say, hey, sine theta is the same thing as y, and cos theta is the same thing as x on the unit circle. Very important that you remember it, goes without saying. Also want you to notice that the size of the circle actually isn't very important in trig ratios because you always get all these triangles that are similar. Okay, so they share this base angle, so here's our unit circle. Excuse my horrible tracing there, with a radius of 1. If you move out to a larger circle, so say the radius is 13, well, these two triangles are similar. Alright, so it turns out that we can always think of sine theta being y and cos theta being x. Alright, that concludes this batch of notes. You'll be able to wrap up that exercise, and we're going to keep on trucking and do the next part of the notes. Alrighty, we're going to get a start on section 6.3, which we're going to start doing, looking at exactly what is a radian, what does this have to do with the unit circle, and all that stuff. So first of all, let's focus on what's radian. Well, there's another way to measure rotations of angles, and that way is radians. So if you imagine a unit circle, if you can imagine your terminal arm, say maybe starting here, and then rotating around the circle, at a certain point, when the terminal arm has traveled an arc, so a curved length of the circle, so when it's traveled, say, from here to here, when that's the same distance as the length of the arm, that's the definition of 1 radian. Okay, so let's say the radius was 2. Well, once that arm has traveled an arc length, which we call s, let's say that that's also 2, well then that's 1 radian. Okay, so the formula for that is s equal theta r, where s represents the arc length. And the arc length is just the curved part of the circle where that arm is traveling. So it's that distance, say, from here to here, that's s, the arc length. Alright, so what exactly is a radian? Well, we can start with the circumference of a circle, and we know that that formula is 2 pi r. Well, on the unit circle, r is 1, so we can just think of it as 2 pi radians. Alright, we know that a circle has 360 degrees, so 2 pi radians and 360 degrees must be the same thing. Okay, so if you were to split up 360 into 180, so if you divide it by 2, well then 180 degrees would be the same thing as pi radians, right? Because remember, 360, that equals 2 pi radians. If you split it up again into 2, so divide by 2, well then that would be pi divided by 2 radians. Alright. Next, there are some useful formulas you can use to convert from degrees to radians and radians to degrees. So if you take this little formula, where we say, well, 360 degrees equals the circumference of a circle, 2 pi r. If you divide both sides by 2 pi, so if you go 360 degrees divided by 2 pi on this side, on the right side, 2 pi divided by 2 pi just leaves you with r. Okay, so that would be 1 radian. We just do some simplification here, now we know that 1 radian is equivalent to that many degrees. So we have a way to convert. I'm just going to go down here for a second, do some examples. Okay, so it says since every radian is equivalent to 180 degrees over pi, you can change radians to degrees using that formula. So if you just multiply pi over 6 by 180 over pi, you will have whatever this is in degrees. So the pi's cancel, and that's key to notice. Usually when you're converting from radians, you got a pi in it, and to get it back into degrees, you want to get rid of the pi, so that's kind of nice. When you go 180 divided by 6, you'll get 30 degrees. let's try another one. We can try the second one here. So just multiply by our conversion factor, like that. The pi's cancel. When you go 4 times 180 divided by 5, you can confirm you get 144 degrees. Beautiful. What if there's no pi? Well, that's fine. So if we got 3.5 radians, then if we want to convert it into degrees, we're just going to multiply by our wonderful conversion factor. And when you do all that math, you get 201 degrees. Okay, we were here. We're going to go to the next slide. So we'll just skip this part because we're going to cover it on the next slide. So flip the page. Okay, if you want to go from degrees to radians, then you're going to multiply by pi over 180. Where does that come from? Well, it just comes from this formula here. All right, now remember, r is 1, so we can sort of drop the r. And we're just looking at that. If you divide both sides by 360, you're going to get, okay, this. So this is 1 degree. So you're going to get 1 degree equals, and if you do the math here, 2 divided by 360, well, that's just going to leave you with pi over 180 degrees. So that's our conversion to get degrees into radians. Okay, so let's do a little bit of practice here. So the first one, you're just going to multiply by pi over 180. And this is so much fun. If you do the math, 45 into 180, you're going to get 4. So you get pi over 4. We don't need to do all of these, but let's just do a fun one here. So if we do 360, we already know from before that 360 degrees is 2 pi. So let's just see if that works. So if we go pi over 180, you do some math, 180 goes into 360 twice, so you get 2 pi, and whoop-de-dee, that's no surprise. Let's try 500 degrees just for giggles. So if you go pi over 180, and if you do some math, do some reduction, stuff like that, you're going to get 25 pi over 9. And you're done that. Let's see what's next. This page is just summarizing sort of everything that we learned so far, so it's pretty handy to stick this one in your back pocket. A central angle of 1 radian is subtended by an arc with length r, so that was just our fancy picture where we said, hey, if you have a terminal arm and it's on a circle, once that terminal arm has traveled a certain distance around the circumference, that's called the arc. If the arc length and the terminal arm length are the same, that's a radian. You can read through the other ones on your own. The important things to remember are the conversions. 1 radian is that, and 1 degree is this many radians. These formulas are not on your formula sheet. Okay, so they're not provided. You straight up just have to memorize them. Sad. Okay. I don't think we need to do this. You know what? I lied. Let's do some of it. So let's do A. So if you have 255 degrees, they want to know the measure in radians. Okay? So if you take the 255, now you're converting to radians. Okay, now the way I used to remember the conversion was I'm converting to radians, so I need to have pi in it, because usually radians have pi. It's just a quick trick to help you memorize. It works in most situations. So if you do the math here, oh geez, I'm not ready for the math. They are saying give the answer to the nearest hundredth. So this is just straight up pop it in on your calculator. You're going to get 4.45. And then you can just write rad for radians. And that would be good. Let's do another one here. No, these all seem boring. Actually, no. Let's do B. So there's A. Here's B. Now I want to do this one because it gives you some angle in radians, and it's not like an exact value that you're needing to memorize. And it says sketch the angle in standard position. Well, if they ever gave you a question like that, you would sort of have to convert it to degrees. Okay, we're not really used to working in radians. Maybe if you had more experience, you could draw that, but I look at it and I'm like, hell, there's no way I can draw that. But if I convert it to degrees, that would give me a better idea of where it lands. So I'm going to take that, I'm going to multiply by my conversion to degrees, and that's 180 divided by pi. And again, the way I used to remember is the pi's got to cancel. So this is the conversion that gets me into degrees. So the pi's will cancel. You'll do some math. So you'll go 5 over 7 times 180. Don't forget the negative. And you're going to get 128.6 degrees. Now I know how to draw that. So that's 0. This is negative 90. And here's negative 180. Now be careful, because on the exam they're going to get really nitpicky about exactly where you're drawing this. So if you drew it in the middle, that would be 90 plus 45. That would be too much, I think. Yeah, because 90 plus 45, that would be 135 degrees. So they want to see you drawing this one closer to the 90. So if you draw it in the middle or past, you're going to lose marks. Who knows how many marks? You're going to lose marks. So I did my best. To me, that looks a little bit too close to the middle, so I'm going to try again. I'm going to try one more time. Mama always used to say, try twice. There, that's a little better. Then you got to draw that like this, and you got to label it negative 128.6. Alright, don't forget the little arrow here, and don't forget the little arrow on the terminal arm. Beautiful. Okay, that's good enough for that. Okay, last topic. So, flip the page. Now, you might have to flip a couple pages before you get here, but the last order of business for today is talking about our unit circle. In grade 11, you guys memorized all the exact values for degrees. Okay? So, in grade 12, what we do is you're still expected to know degrees, but we add on radians. And most of the things we're going to do is we are going to be focusing on radians, but sometimes you see questions where they ask for answers in degrees on the exam, so get comfortable with both. Now, I don't know how you guys memorized it in grade 11 if you were in other classes, but you only really need to focus in on quadrant 1. So if you memorize the values for 30, 45, and 60 degrees, you've done the bulk of the memorizing. So this is how it works. Again, this has both degrees and radians. So 30 degrees is equivalent to pi divided by 6 radians. Okay, now the terminal point for this angle here is the point square root 3 over 2 and a half. Now I want you to notice something. The reference angle here is 30 degrees. This is why you only need to memorize these three values. If you go over here to 150 degrees for a moment, okay, so 150 degrees or 5 pi over 6 radians, check it out. The x value is identical, square root 3 over 2, right? Same as over here. The y value is a half, same as over here. Well, why is that? That's because the reference angle is the same. Okay, so the reference angle here is 30 degrees because this is 150, this is 180. Okay, so the conclusion is if the reference angle is identical, the point is, oh, sorry, my mic is really horrible. I don't know what happened to it. It used to be a good mic. Anyways, so if the reference angle is the same, the point is the same. The only difference are the signs. Okay, so you'll notice here that it's actually negative square root 3 over 2. And the reason for that is in quadrant 2, x values are negative. Okay, so if you memorize 30 degrees, 45, and 60, which are pi over 6, pi over 4, and pi over 3, if you memorize those and you know how to use reference angles, which is something that's all we're going to do from now until the end of the unit, if you can do that, you don't need to memorize anything more than that. So check this out. I'm just going to erase it for a second. So that's a reference angle of 30 degrees. Well, if you go and you look at, say, 45 degrees, okay, so reference angle 45 degrees, if you go off in quadrant 2, so this is 135 degrees, so this reference angle is 45, right? 135 plus 45 is 180. Check it out. The point is identical. The only difference is that the x value is now negative because you're in quadrant 2. Okay? So you can remember that this is pi over 4, this is 3 pi over 4, and hey, how do you get 3 pi over 4? That's weird. Well, actually, no, it isn't, because if you think of this as 0 degrees, okay, this is 90. Remember, we went over it before. 90 degrees is pi over 2. This is 180 degrees, or pi. Well, check this out. If you go pi, subtract that reference angle pi over 4, you will get 3 pi over 4, right? Pi is 4 pi over 4, right? Getting a common denominator. Subtract pi over 4, hey, that's 3 pi over 4. Okay, over time you will actually slowly begin to remember, pi over 4, 3 pi over 4. Here it is down here, 5 pi over 4 and 7 pi over 4. So you can sort of memorize that, or you can just use the fact that you know the reference angle is pi over 4, right? So if you go pi plus pi over 4 to get this one here, you will get 5 pi over 4. Believe me, it is way easier to memorize 3 things rather than all of this. In time, if you do enough questions, you'll actually begin to memorize it. But by that time, you'll be so good at doing the calculations that it won't matter. Okay? So memorize the unit circle. Do it however you like. My suggestion is memorize just these 3. Okay, then you'll have to sort of memorize these points, right? So 90 degrees is the point 0, 1. Remember, we're on the unit circle, so it's no surprise that when the terminal arm is straight up at 90 degrees, the radius is 1. Okay, so these are relatively easy to memorize. You're just going to have to memorize, 90, 180, 270, and 0 or 360. Okay, so good luck. You can start the homework. You can go and do the questions that we've done. It'll be the first couple in 6.3. We got another 2 days on this lesson, so good luck.